Hi everyone, welcome back to my channel Science with Sangati. So today we are going to discuss on the topic Newton's first laws of motion. Okay, so all of you can take out your notebook so that you can note down the important points. And if you have not already subscribed to my channel, please subscribe it. Alright, so you can watch a lots of videos, lot of study videos regarding your syllabus and some interesting facts also. Okay, so let's get started. So first of all, the Galileo Galilei first of all said that like he gave the idea about the law of motion. Okay, so he said that the object is going to move in a constant speed when no forces are acting on them. Okay, so basically he observed the extraterrestrial objects like the planets and all. He observed that. So he said that like they are moving in a constant speed and there no forces are applied on it, so it is moving in a constant speed. So basically if there is no friction, no gravitational force, no any other force, so the object is going to move forever with the same speed or same velocity. Okay, so that is there is no unbalanced force is working on that object. So this was said by Galileo. But on the earth, practically, it is impossible for any object. Why? Because on earth, there are some kind of forces are always acting on any kind of any object, right? So because to attend the condition of zero, unbalanced force is impossible. Okay, so on the earth, even if something is in the air also, there is drag forces applicable on that object, right? Or any kind of force like it is applicable on the earth. Friction is always there. A minimum friction, even you make a surface, try to make a surface very smooth, still there are air is present. Okay, little bit of friction will be there. Okay, okay. So it's kind of a very challenging task on the earth. All right, so this was the said by Galileo. So force of friction, force of air and many other forces are always acting on that object if the object is present on the earth. Okay, so Newton studied these ideas of Galileo and gave three laws of motion, and these are also called as Newton's laws of motion. So today we are going to just discuss about the first law of motion, which is also called as law of inertia. So first law of motion is saying that if the object is moving, it's in a uniform motion, it will remain in the uniform motion until and unless we apply any other force, any other external force is applied. Or if the object is at rest, it will remain it's at rest only. So until and unless we are applying any other external force. Okay. For example, if you have any table at your home, so table is not going to move by itself, right? Table will be there only until and unless you are applying the force to move that table and change the position of that table, right? So any object will remain at rest until and unless we are applying any kind of external force. Okay? Or suppose a ball is moving. So like playing the football, you have kicked the ball is moving. So ball will also stop at some point, right? So when it is going to stop, so if there is any other opposite force is acted on the ball, like frictional force or any drag force, then the ball will definitely stop. So if the ball was moving, then it will stop. So this is the basically Newton's first law of motion. Now, when like when you are moving a table, suppose you have a very heavy table and now you are moving a stool. So which one will be more easier for you to move? Of course the stool, because stool is very small, right? But the table is like huge table, right? So basically every object has a tendency to resist the change of its state of motion or rest if both the table and the stool are at rest position only, right? But when you are trying to applying the force on both of them, you in on table you have to apply more force, but in stool you can just move it very easily. In less force, you can move the stool, right? So basically it shows that that object is also resisting itself to change its state of rest, and this tendency is called as inertia. Okay, now inertia is depending on what? It is basically depending on the mass of the body. So like the table is having more mass, so you have to apply more force, because more the mass, inertia is increased, and then you have to apply more force. And lesser the mass, it has less inertia, and you can just move the object very easily. Okay, in less force also you can move the object. Okay, so this is the inertia of rest. Similarly, it occurs for the inertia of state of motion also. So basically we can see that there are two types of inertia: inertia of rest and inertia of motion. Inertia of rest states that object is remaining at rest until and unless an external force is applied on it. Like it has the tendency to remain at rest. Like for let's take another example. Like if you are sitting in a car or any bus, okay, or any kind of vehicle, anything. So what happens when the vehicle start? Our body falls backwards, right? It moves in the backward direction. Why it happens? Because our body is having some mass, and our body is trying to maintain its rest position. Okay, that's how our body, the upper, especially the upper part of the body, it falls in a backward direction when the starts on the when the bus starts. Okay, so this is the basically inertia is making their body stay in the place as the car is moving forward. So car is moving forward, but our body tends to stay in the rest position only. So that's why it moves in the backward direction. Vice versa for the inertia of motion, an object will be continued to in motion until the force is acting. So same thing, let's take the example of the car only. Suppose the car is moving and you are sitting on the car and the driver applies a brake suddenly. What will happen? You will move in the forward direction, right? Why? Because again of the inertia of the motion. Now your body is in motion, so your body has a tendency to be in that motion only. Okay, but suddenly the car stops, your body didn't know, so it moves in the forward direction because your body has a tendency to be in the motion, and that is called as the inertia of motion. Okay, here a hockey example is given. A hockey puck will continue to slide across the ice until acted upon the outside force. So there are numerous examples. We will be discussing of other examples also. But before that, let's watch a video.
Imagine you're sitting on a recliner chair watching your favorite movie on a lazy Sunday. And your mom calls out your name and asks you to run some errands. You can imagine how difficult it would be for you to get up and do the work. Imagine you're practicing for your 100 meters race on this track, and somebody asks you to stop immediately within a second. Will you be able to do it? What if you're suddenly asked to turn towards the right? Will you be able to turn immediately? The answer to both the questions would be a no. You can stop, yes, but gradually. You can also turn, but not sharply. And guess what? It's the same story with every object. Every object will continue to do what it's doing. If it's at rest, it will remain at rest. And if it's in motion, it will stay in motion. But what can change this? Yes, only an unbalanced force can change this. If it's at rest and an unbalanced force acts on it, it will move. If it's in constant motion and an unbalanced force acts on it, it may accelerate or change direction. And this is nothing but the Newton's first law of motion. Here's the correct definition. An object at rest stays at rest and an object in motion stays in motion with the same speed and the same direction unless acted upon by an unbalanced force. In simple words, it means that the objects continue to do what they're doing unless some external unbalanced force acts on them. We can also understand this using a simple diagram. If the forces are balanced, there can be two cases. An object may be at rest, or an object will be in motion at a non-zero constant velocity in a particular direction. These can be the only two cases when the forces are balanced. In the first case, the object will continue to remain at rest, and in the second, the object will continue to stay in motion at the same velocity and in the same direction. Don't forget, these two cases will remain true only if the forces are balanced. In the next video, we will look at a few applications of the first law of motion.
Alright, so here you can see there are a few examples. A person standing in the bus falls backward when bus moving suddenly. So we have already discussed this. This is happening because the person and bus both are at rest, but when the bus was not moving. But when the bus start to move, the legs of the person start moving along with the bus, but rest of the portion, like the upper part of the body, has a tendency to remain in rest. Because of this, the person falls in the backward direction, and especially when he is not alert. Okay, so person standing in the moving bus falls forward if driver applies the brake suddenly. We have already discussed this one. So this happens because when the bus is moving, the person standing in it also in motions along with the bus. But when the driver is applying the brake, speed of the bus decreases suddenly and it comes to rest. And our body has the tendency to be in the motion. That's why rest of the part of the body uh, uh, they just fall in the forward direction. Okay, while the our legs comes to rest immediately along with the bus. So this is the example from everyday life. Few more examples, let's see. Before hanging the wet cloths over laundry line, usually many jerks are given to the cloths to get them dried quickly. Because of jerks, droplet of the waters from the pores of the cloth fall on the ground and reduce amount of water in the cloth dries them quickly. Okay, and so this occurs when we are just trying to dry some our clothes. We jerk it so that water droplets fall down. Okay, so this is and one more example I can give you about the trees, leaves present in the tree. So if you are jerking the trees, if you are pushing the trees, okay, shaking the tree, so what happens? Leaves also fall down, right? Why they fall down? Because the leaves were in the tendency of being in rest. But when you shake the tree suddenly, so they try to remain in the rest. So, but the branches are moving. That's why they get detached from the branches. Okay, and that's why the leaves fall down. So this is all of these examples are of the inertia, law of inertia, or Newton's first law of motion in the everyday life. Okay, this is it for today's video, students. I hope you have enjoyed the video. Thank you for watching my channel. If you like this, please hit the like button, subscribe to my channel, and share this with your friends. Take care. Have a nice day. Bye bye, everyone.